Watch what happens when you type a simple prompt for a login page. In seconds, complex authentication logic and interface components flood the screen. But push that exact code to a staging environment, and the reality hits. The permission check is broken. A database migration fails. You are immediately looking at an exposed security vulnerability. For decades, the industry measured a developer's progress by volume. Your worth was directly tied to how much implementation code you could manually type out. Now, a machine can generate that same volume of boilerplate instantly. The traditional definition of what it means to be a software engineer is breaking down. If the machine takes over the typing, do human developers become obsolete? AI is compressing the labor of implementation. As the time spent on writing code shrinks, the engineer's focus moves toward the tasks the machine can't own: defining the problem, designing the system, and verifying the result. A lot of the anxiety right now comes from confusing two completely different things: code generation and software engineering. AI is exceptionally good at writing first drafts and churning out repetitive boilerplate. You can generate API handlers and UI elements continuously, but code is not a working product. Between that raw text and a reliable system lies the implementation gap. AI doesn't know your business context, who your users are, or what happens when your infrastructure fails under load. Inside that generated stack, you will find hallucinated API calls, ignored concurrency limits, and silent failures waiting to trigger. The danger is that these specific errors masquerade as correct logic. They pass a quick visual inspection and run perfectly in an isolated test. Because AI makes weak execution incredibly cheap, it makes human architectural mistakes infinitely more dangerous. You can now build the wrong thing poorly at lightning speed. When machines overproduce code, the immediate bottleneck in development shifts entirely to human comprehension. That starts with problem framing. A vague instruction like build checkout gives you vague, fragile software. You have to establish strict constraints: validating stock, handling payment failures, and reserving inventory. Then comes system design. Before you generate a single line, you have to decide if a workflow should be synchronous or asynchronous. AI can write functions, but it doesn't fix a bad architecture. You also have to manage the blast radius. Giving AI tools access to your files, terminals, and databases requires strict boundaries on what those tools can read, edit, or delete. Verification changes completely. You have to stop asking, "Does this code look clean?" and start hunting for exactly where the generated logic will break when thousands of users hit it at once. Clean code, specifically isolating risky patches and unfamiliar, machine-generated files, is now a daily survival skill. And when things break, you must isolate the root cause and form a specific hypothesis. If you just ask the AI to blindly guess a fix, you aren't debugging. The human engineer acts as the reviewer, the debugger, and the safety net. You serve as the bridge between raw, generated text and a secure, reliable system. So what does this mean for junior developers? The reality is that basic, beginner-level implementation tasks, the simple CRUD apps and repetitive scripts, are effectively gone. Passive learning is now a severe career hazard. If beginners simply accept AI output without understanding why the underlying systems work, their technical growth will stall permanently. To build real value, early career engineers have to intentionally study system design, rigorous testing, and failure handling. Engineers who maintain strict judgment while using AI to increase their throughput become significantly more valuable than those who trust the machine blindly. For decades, the job was defined by the ability to write code from scratch. Now, that same job is defined by the ability to guide AI tools and own the production outcome. The modern software engineer operates under a new definition. I turn ambiguity into reliable software. AI changes the daily mechanics and the speed of the job, but the ultimate responsibility for the safety, security, and existence of the system remains entirely human.